Hello, welcome to the course Excelling with Mathematical Modeling. Today we will be talking about a very interesting model, namely the mathematical model of the dynamics of alcohol. Well, many people, we think that drinking as an integral part of our social life, and they believe that the quality of social life is enhanced by moderate drinking without understanding the risk involved in the consumption of alcohol. And as you have noticed, most of the traffic accidents, actually 45 to 55% of the traffic death occurs in India due to the influence, because people are driving under the influence of alcohol. Now, to model this dynamics of alcohol, that is how this alcohol works inside your body, we need to know few things. The very first thing is, what is BAC? That is blood alcohol content. So, you must have heard or seen, even noticed that often the traffic police, they use some sort of device to measure the alcohol content in a body. So, you have to take a breath. So, here this blood alcohol content comes. So, BAC of 0.1 means 1 gram of alcohol is present in 100 ml of blood. So, the legal limit in India is 0.03% per 100 ml of blood, and this is easy to remember, that 30 milligram of alcohol in 100 ml of blood. So, that is the permissible limit. And a standard drink, if you take 350 ml of beer, will raise your blood alcohol content of a 68 kg adult male to 20 to 22 mg of alcohol in 100 ml of blood, which is permissible. However, the count is different in a female. So, if you look into the dynamics of alcohol, and if you watch the video, you will see that once you first take the alcohol, so it touches the tongue. So, the very first thing is your alcohol enters the body through the tongue. It absorbs a little bit, but it's goes into the stomach, and if you have taken some food, then it is fine. Otherwise, from the stomach it directly goes to the small intestine, and where it is easily absorbed with the bloodstream. So, all the alcohol of one drink is absorbed within 30 minutes. However, if you take some food, and then what happens is that alcohol is trapped with the food, and it finds it difficult to pass to the small intestine. So, that is why it is always advisable that when you take alcohol, take lot of food. In that way, it will affect your body in a much lesser time. Now, the main content of this alcohol is ethanol. So, the first is the metabolism of this ethanol by the liver enzymes, and the second is the filtration by the kidneys. And the average rate that the alcohol leaves the body is 50 milligram per 100 ml per hour. So, if a person has 75 milligram of ethanol or alcohol in his body at the beginning of the hour, then the body will eliminate 15 mg in the next hour. So, that is the easy calculation. Now, if I want to model this one, say I take AN, it is the amount of alcohol in a person's body at the beginning of hour n. And as mentioned before, the person's average elimination of alcohol is 15% from his body each hour. So, if AN plus 1 is the amount of alcohol in n plus 1th hour, that is AN in 1 hour 15% is eliminated plus some E. So, what is that A? It is the amount of alcohol consumed in each time period. So, it is A n plus 1 equal to, I can generalize it, minus R times A n plus E. This is the fraction filtered by the kidney, by the body cell. Now, here is the thing. So, we have assumed that the alcohol leaves the body at a constant rate of 15%, but in reality this really does not happen, because the metabolism of alcohol or ethanol does not happen to be at a constant rate. Its speed difference is different for different people. So, what you do is, instead of taking R to be a 15% constant, you consider it as a function of A, that is the amount of alcohol that has been taken. And we also assume that this Ra goes to 0 as the amount of alcohol in the body gets larger. So, basically what happens, you consume more and more alcohol, and the rate you are taking the alcohol, the body cannot get dispose of that. So, ultimately that rate at which the kidney functions almost becomes negligible. So, that is the assumption. So, for such assumption, we consider two such functions. One is this rational function, another is this exponential function. Now, let us see how these two functions behave. We will use Microsoft Excel to get the graph of these two functions. So, already I have the file. Here is the function Ra, the rational function, and this is the exponential function. So, first rational function and second rational function. I will come to what is this Fa. So, the first one is, this is equal to 1 by 1 plus A, there is P5, and this is equal to 1 by, or you can write this as exponential minus A. So, exp of minus A. So, I get both of them. Let me drag to 20 such values and you get something. Let me now plot them. So, if you highlight them using shift key, then go to insert, choose the charts and this one. So, what you can see is that as you take more and more alcohol, your rate will ultimately become less and less, the rate at which the body disposes of the ethanol or alcohol. So, both are decreasing function and goes to 0 as time passes. Now, the filtration, which is denoted by this Fa, it is defined by the rate at which the alcohol content is disposed of multiplied by the alcohol content. So, this is the rate Ra and it is multiplied by A in both the cases. So, let us see that how this works, what kind of graph we get here. So, this is equal to A times, which is this, multiplied by Ra, which is this, and this is equal to again A times multiplied by this Ra. So, let me drag them. So, if I now plot these two, so So, to highlight this other two columns which is not side by side, you press the control and you press click and then press the shift button and press downward cursor key and they will all be highlighted. Similarly, you press the control, you press highlight this cell, press shift and down cursor key. So, both of them are highlighted. Go to insert, go to this chart and this curve. So, what conclusion we get from these two graphs? Let me go back to the slides. So, as discussed that we take the function R A in such a manner, that is the rate at which the alcohol being disposed from the body, as a function, rational function 1 by 1 plus A and an exponential function 1 by e to the power A. So, this is a rational function and this is an exponential function. If both are plotted, you see that both of them goes to 0 with time. So, we can choose both the functions at the rate. Now, so the first one is the exponent is the rational one 1 by 1 plus A and the second one is e to the power minus A. Let us now see what is this FA. So, it is the filtration rate of the alcohol by the kidney per hour and the amount of alcohol filtrated, that means eliminated from the body, is the product of the rate R multiplied by the amount of alcohol. So, the function multiplied by the amount of alcohol. This is the rational one, this is the exponential one multiplied by A. Now, if you see the graph, so the first one, this is for the rational R divided multiplied by A, this is for the exponential R multiplied by A. So, the first one says that as the amount of alcohol increases, the amount of filtration also increases, and this one says as the amount of alcohol increases, the amount of filtration decreases. So, this one seems to be reasonable, and that is what we will take, that the rational function multiplied by A as our F. So, what we do now is we have taken the rational function as 1 by 1 plus A, but we will make it a generalized one. So, the generalized function which we take R to be some beta by gamma plus A n minus 1 or gamma plus A also. Now, we need to find or estimate the value of this beta and gamma. So, beta and gamma, they are constants depending on a particular person. And what kind of data you need to calculate this beta and gamma? So, for example, that a blood test is performed on a person who was caught driving under the influence of alcohol, and it is found that 21 grams of alcohol shows 40% filtration, and with the same person 36 grams of alcohol shows 25% filtration. So, now if we put the values here, what you will get is that I do not know what is beta, I do not know what is gamma, but I know what is this A, that is 21 grams of alcohol, and the filtration rate is 40%, so 0.4. Similarly, beta by gamma plus 36 will give me 0.25. So, from here if I just divide, I will get 0.4 by 0.25, that is equal to beta by gamma plus 21, beta by gamma plus 36, gamma plus 36 by gamma plus 21, and that is equal to 8 by 5. So, simply cross multiply 5 gamma plus 180 is equal to 8 gamma plus 168. So, 3 gamma is equal to 12 implies gamma equal to 4. And with gamma equal to 4, if you substitute it say here, so beta by 4 plus 21 is equal to 0.4 and beta equal to 0.4 into 25, which is 10. So, you got your gamma is equal to 4 and beta is equal to 10. So, now your model will look like, so your A becomes 10 by 4 plus A, and your model is A n plus 1 equal to A n minus 10 A n divided by 4 plus A n plus A. So, if you recall that the alcohol content in the n plus 1th hour is the alcohol content, the present one, minus in 1 hour we have told that 15% leaves the body, but now we say that it is a variable quantity. Instead of 15%, you take the rational function, which is 10 by 4 plus A n multiplied by this A n and plus A, which is the constant input of the alcohol. So, this becomes your model now. This gives the dynamics of the alcohol in a body of a particular person. Now, let us look into the equilibrium solution. So, the equilibrium solution means there is no change from one generation to another generation. So, we replace this A n and A n plus 1 by some A star minus 10 A star by 4 plus A star plus A equal to 0. This and this cancels and you get 10 A star by 4 plus A star equal to A. This implies 10 A star equal to 4A plus A star, and you will get 10 minus A into A star equal to 4A, which implies A equal to 4A divided by 10 minus A. And since it is the alcohol content, you must have 10 minus A greater than 0, that is A must be less than 10. So, that is the condition for the existence of a positive equilibrium solution. So, once you get the equilibrium solution, then you go for the stability analysis. Here the model is A n plus 1 equal to A n minus 10 A n by 4 plus A n plus A. So, let some G A is equal to this whole thing, A minus 10 A by 4 plus A plus, where your A star is given by 4A by 10 minus A, and this is your equilibrium solution. So, let us look into the stability at the point A star. So, you have to find G dash A, and that is 1 minus 10. So, this is 4 plus A minus A divided by 4 plus A whole square. So, if you differentiate this using U by V, you will get this and this cancels, and you get 1 minus 40 divided by 4 plus A whole square. Your G dash A star will be 1 minus 40 by 4 plus A star whole square, where A star will be substituted here. So, your G dash A star is equal to 1 minus 40 divided by 4 plus your A star is 4A divided by 10 minus A whole square, and this will give 1 minus 40 minus 4A plus 4A whole square, here 10 minus A whole square. So, 140 cancels, and you are left with 1 minus 10 minus A whole square divided by 40. Now, for the system to be stable at the point A star, you must have G dash A star must be, modulus of that must be less than 1. So, this will imply 1 minus 10 minus A whole square divided by 40, mod of that must be less than 1. So, if mod of this is less than 1, which means this whole thing lies between minus 1 and plus 1. So, let us quickly solve the inequality. So, after this step, we just simplify this, and I have minus 1 less than 1 minus 10 minus A whole square divided by 40 less than 1. So, if I consider this two, I will get 1 minus 10 minus A whole square by 40 less than 1. This and this cancels. So, I get 10 minus A whole square greater than 0. So, if I change the sign, I have to change the inequality sign also, and this is obvious. If I take minus 1 less than 1 minus 10 minus A whole square divided by 40, this will give me 10 minus A whole square divided by 40 is less than 2. So, this I bring to this side and this to this side. So, this will imply 10 minus A whole square is less than 80. Again, this will imply minus root 80 is less than 10 minus A is less than plus root 80, which is minus, this is 16 into 5. So, 4 root 5 less than 10 minus A less than plus 4 root 5. You subtract 10, 4 root 5 minus 10 less than 10 minus A minus 10 less than 4 root 5 minus 10. This will give, so there is a negative sign. If I multiply this whole thing by negative, you will get everything but with opposite equality sign. So, I will get, here it is A, this thing will come to this side, that is 10 minus 4 root 5, and this will be 10 plus 4 root 5. If you want to take the numerical value, this is 1.06 less than A less than 18.94, but already shown that A has to be less than 10. So, combining from the existence, we already have A to be less than 10. So, combining these two, I will have 1.06 less than A less than 10. So, the conclusion is, for this model which captures the dynamics of alcohol, the content of alcohol every hour must lie between 1.06 to 10 units, such that the system is stable. We now look into the numerical solution of this alcohol model, where we have substituted the value of A to be 2. And as we have shown before, that the equilibrium point of this model is given by A star equal to 4A divided by 10 minus A. So, if we substitute your A is equal to 2, your equilibrium solution will be 4 into 2 divided by 10 minus 2. So, 8 divided by 8, which is 1. So, your A star will be 1. So, with this information, we now solve this particular alcohol model using Microsoft's Excel, where we have taken the initial condition to be 10. So, we first put this is equal to 0 plus 1. So, we give an increment of 1 and drag it so up to say 30, 25, a little more 30 values. Now, this initial value we have taken to be 10, you could have taken any number. So, this will be equal to AN, this is the initial value A0 minus 10 times again A0 divided by 4 plus again A0. I put again this in a bracket plus A, and the value of A is constant. So, I put $sign and you calculate this value. So, I drag it a little more because I already know the value will be 1. Yeah. So, let me drag this also a little bit. So, let us make it 50. So, to plot this, we highlight them, select all the 50 values, go to insert this chart and click this. So, basically you see that this equilibrium point, it reaches the value of 1, which matches with your analytical solution, and the system is stable because the value of A lies within the range of stability which we have proved before. So, this is alcohol model. If you want, I remove the grid lines. I want an axis title. So, basically this is time and this is the amount of alcohol. So, you get the model where you have shown that your numerical results matches with the analytical results because the system is stable and it reaches the equilibrium point A star equal to 1. So, summing up, today we have learned about an interesting model, namely the dynamics of alcohol in the body, where we saw mathematical functions which controls the amount of alcohol in the body. We also consider a model which shows the dynamics, and it is investigated. We find the equilibrium point, the stability condition depending on value of some constant A, and we see the results numerically also, and we found that the analytical result matches with the numerical results. So, in my next lecture, we will be talking about some linear prey predator model and see the dynamics among them. Till then, bye bye.